What's up, everybody? Lars here. Time for the very last review video for Unit 5. As of now, you should have read the slides, read the book, seen the assignments, started thinking about a deck of cards and different things like that. But we still have one last thing to do. You know about it because it was in the slides, but I really do want to review a couple of the extra things that come along with object-oriented programming. They're not really big enough to be subjects in themselves, like inheritance and polymorphism, but they're neat things to know. Like class variables are important, especially if you do game programming. You want to keep track of, let's say you had a class for an enemy and you created 100 of them, and every time one got killed, you wanted to track how many were alive and how many were dead and things like that. Well, class variables allow us to do something like that. And then deconstructors are interesting because they were popular back in the 90s when people were getting hot and heavy with C++, but Java doesn't really have them. Actually, you can use them in Java, but a lot of people don't. And right now, we're so lousy with memory that people aren't worried about, getting rid of their objects. They just let them sit out there because we have so much memory that it doesn't really matter. But I digress. So for now, here's last semester's lecture on class variables, deconstructors, and overriding functions. You're going to learn about overriding the string function so that when you print your object, you can print whatever your little heart desires. All right? And then afterwards, we're going to come back and we're going to do some announcements. But there's not a whole lot of announcements because we are pretty much ahead of the game and things are winding down. So you guys are in pretty good shape. All right, without further ado, the last review video for Unit 5. Here it comes. Bye. Hey, everybody. Lars here. Time for the last of the 3 review videos for Unit 5, the big bad unit on object-oriented programming. But as you can see, it's not so bad. Actually, if you get a lot of examples and you practice and you try things and you read the book and you read the slides, you find out it's a little different way of doing things, but it's not really that crazy. Today we're going to jump right in because I looked at the last video I did for this, not the one in the summertime, but the one last spring, and it was 45 minutes, and I don't want to go that long. So I'm going to get started right away. Basically what I've done is, do I need that? Do I need that? Well, that no longer exists, so let's get rid of that. I am going to bring up the animals file that we used in our last video, which I shot last night. I'm shooting this Sunday night. Cowboys won, Giants won, Eagles lost, Patriots are beating the Niners as I speak, just in case you needed a little update. We had our animal class, we got our cat class, and then I used them both. And basically we played around with how we create classes, constructors, getters, setters, methods, things along those lines. And we use them to create objects that we use in our programs. The previous video, we went over some stuff with inheritance, how we can use already created classes to, just build a little bit on top of them. And polymorphism, how different things can have the same name, but they can work differently depending on their context. Today, we're not really going to introduce any massive, huge, new concepts, but we're going to go grab some knicky-knack stuff that I think you should really know when you deal with object orientation, but it doesn't necessarily lend itself to being a unit or a week in itself, learning all these things. They're little knicky-knack things, little pickup things, all right? First thing I'm going to do, and I think I do this usually when I do this unit, is see this cat class? Watch this. I'm going to copy it, and I'm going to come down here, and I'm going to paste. So now I have cat twice, only I'm not going to leave a cat. I'm going to make it dog. And then I'm going to come down here and I'm going to make the dog say woof. And boom, look at that fast. I now have a dog class. You can see, it's the same thing as animal, name, weight, and then a color, which is the same as cat, but animal doesn't have color. So now I can create a dog, and if I tell the dog to speak, it says woof. If I tell the cat to speak, it says meow, polymorphism. So let's see, I will leave that cat there, I guess. And now I can say D1 equals dog, and I'll call the dog Fido, and Fido will be 35 pounds. That's not so bad for a dog, and we'll make Fido brown. Okay? And then we'll print all Fido stuff, and I will just steal that, copy, paste, and then I will go change the variable names so that I'm getting stuff for Fido and not Felix. And that's pretty good. All right, let's create one more dog. I'll say dog, and I'll call him Rex. And I'll make Rex a big boy. And I will say that Rex is, let's say, red, big red dog, an Irish setter. And then we will do the same thing we did. D2, D2, and D2. All right. So now, when we run this, we're going to get 3 objects. C1, which will be a cat, D1, which will be a dog, D2, which will be a dog, and they should print out their attributes, and they do. So we're in pretty good shape. All right, real quick trace. C1 is a variable that holds an object that was created with a cat class. You come up here to cat, you ran the constructor, you went and got your animal with the first 2 variables, and then created a color, and then you came back. So when you printed, C1 is what? It's a variable, it points to the cat object, get name. Is there a get name in cat? No, but there is an animal, so what's the name? In that case, it was Felix, blah, 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 and you know the rest of the deal. Now with dog, we do the same thing, only we went to dog, okay? And when it said get name, it didn't find it, but dog inherited from animal too, just like cat does. So dog went up here and found get name and used it from animal and ran things that way. You can see Felix 15 orange, Fido 35 brown, Rex 50 red. You can see all our parameters being spit back at us, okay? Now, you'll notice that when we have our instance variables, all of these variables set up for their particular object. But Rex, the dog, D2 here, doesn't know anything about Felix the cat. Fido, the dog, doesn't know anything about Rex, the dog, okay? These are all instance variables. So when you have a variable, it basically holds its own information, but really doesn't share information. What if we needed a way to share information between these different objects? There's a way to do it, and there's a way to set up a variable that any object created with a certain class can access, and they're called class variables. And the way we do them, now what I usually do at this point is I say, hey, I got all of these different animals. I got Felix, Fido, Rex, boom, boom, boom. Wouldn't it be nice if I kept a counter so I always knew how many animals I had? So given this code and object orientation, how would we implement a counter? Get some coffee. And the way we would do that is to use something called a class variable. So what I'm going to do is I'm probably going to do it up here in animal. And as you can see in the constructor, you set up the different instance variables that are going to be kept for the object, the instantiation of the class. But what you don't know, and what's a little inside baseball, is that whenever you use a class, off to the side, Python creates an object that controls and manages what goes on with that class, okay? And in that particular little object that only has one instance for the class, we can keep things called class variables. And the way you declare them, you don't really declare them, but you can have them, and I will call this a count for animal count, is you have them outside of the methods, outside of the constructor, outside of things, and just hanging out right there, okay? So we have a class variable. We created it inside the class. Now we want to use it. So if I come down here and I say C1 equals cat, boom, 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 what's the logical place to click a counter and say, okay, now I have a cat? Well, in the constructor, when you create. Now, you can do it here in cat, but basically we're going to do it in animal because we want to count all the animals. So if you run it for a dog, it'll go, and if you run it for a cat, it will go, okay? So where's the logical place to put it? In the constructor. So basically what we're going to do is we're going to say a count plus equals 1 here, okay? Now, if I ran this, it would explode. Do I want to show? Yeah. Boom! It explodes. Because, and it's weird because we just created it up here, this method doesn't know what a count is. It's not an instance variable. It's not something it can really see yet. We need to tell it explicitly, hey, this is a class variable, and it's a variable of the class animal, okay? It's not a self situation. We know what the class name is here when we're creating it. It's animal, Okay, so now if we tell it to increment that and we run things, we're back to normal. Okay, you always, when you have class variables, have to tell it what class. All right, so now every time we create a animal with the animal class, we're going to click that counter. But right now, there's no way to know that because we have no way to print that result. So what I'm basically going to do is I'm going to create a getter for the class variable. We don't really need a setter because the logic of our program, whenever we create an animal, we are going to click that counter. That's how we're going to set the variable. So that's kind of our setter in this instance. I'm going to say get a count self, and it is going to return, not retrun, it will return animal.account. And that's it. So that should return it. So now when we come down here and create our little guys, we will print c1 dot get account. Save. And if we do it after every one, copy, paste, save, run. See? After Felix, 1. After Fido, 2. After that, 3. I guess if we wanted to, we could say there are seen animals. And that would work. Let's see. Copy, paste, save, run, and there we are. Okay. Now, if you're clever, you've noticed something. What have you noticed? You've noticed that here, when I call get a count, I use C1, I use the cat variable. I didn't change that variable down here. So I'm accessing the class variable through the same object every time. I don't have to. I can access that class variable through all of the classes. Runs the same. Any class that was created, any object that was created with that class has access to the class variable, which now sits at 3. Okay? So that's the way that we do class variables. You can set them up there, and all of the objects you create with this class will have access to that variable. And what you do in the class is you set up a way to either increment it, decrement it, set it, and you can have getters and setters. But every object, it's almost like a good way to pass messages between objects and to let them know what else is going on by using class variables. It's very handy if you are a game programmer and all of a sudden your object is, let's say, an enemy. And when you get rid of an enemy, you want to update a scoreboard. Well, if your scoreboard is tied to class variables, you can very easily just change the class variable and boom. Okay. Speaking of enemies in a game, I have 3 classes here. The animal, I have cat and dog, which both inherit from animal. I now have a class variable called account, and it clicks every time I create an animal. But, and here's the next thing we're going to take a look at. What if I wanted to get rid of one of these animals? What if I had to delete one of these objects? Back in the day, in the 80s, when I was a kid, when I was learning, memory was scarce. Memory wasn't as all over the place as it is now. We're lousy with memory. Memory is cheap. You have 16 gigs of RAM on your machines. When I was a little kid, I paid a lot of money. My mother took a loan out actually from the AT&T credit group so that I could buy a AT&T PC with a Pentium chip and 8 megs of RAM. 8 megs of RAM. And I got that instead of getting a 486 with 16 megs of RAM. Actually, my Pentium chip had the FDiv bug. Look that up and check that out if you want. FDiv bug. Anyway, as usual, I digress. Back when you learned object orientation in the 80s and 90s, you were careful with your memory. When you created an object, you used it. When you were done with it, you had to get rid of it because you wanted to take all the memory you used and give it back to the program, or back to that special area called the heap where the program goes and gets all its stuff. Now, nowadays, it's kind of different. We're lousy with memory. We have a lot of memory. If you know anything about the Java memory model, most people don't care about garbage collection nowadays. That's what it's called when you go back and get your memory back, garbage collection. And so a lot of people now, in this day and age, when you get taught object-oriented programming, people don't even look at getting your memory back anymore. And you do it with these things called deconstructors. A constructor is a method that runs when you first create your object. The deconstructor is its polar opposite. It is the method we run when you destroy an object. You might be saying to yourself, well, how, I don't know how to destroy an object. It's very simple. And what we're going to do is we're going to make it a dog party and destroy Felix. DEL. See how Idle made it orange? DEL deletes objects. And then you just say the object you want to delete, and boom, it is gone. Okay? Now, I could just run this, and it would be deleted, and it would be fine. Because what you're going to learn is that when you create classes, there's an overarching, godlike class called the superclass. And it has little default methods for all of the different dunder things we've been looking at. Okay? Dunder init is the main one. Now we're going to learn a second one. Okay? And that is, you see, def init. I usually go to the bottom. And we call it del. Del is what we call a deconstructor. Del is the method that is going to run when we destroy an object. So I'm just going to say print self.name. We'll bark out what the thing is. Has been destroyed. And then I am going to say animal.account, and I'm going to decrement by 1 because I'm destroying the object. So when I destroy it, I'm going to say print this has been destroyed, and I'm going to decrease the count by 1. So when I come down here and I delete that, I'm going to want to print. Copy. Paste. There are D2. Now you notice I'm not using C1 here because I got rid of it. You've got to make sure you don't, when you delete an object, don't use it to access variables and different things like that, but I haven't done that. So I should be okay. Now, when I redo a count, it should say 2 because I had 1, 2, 3, then I got rid of 1, so now I've dropped back down to 2. Let's see if we did things right. And we have. Felix, 1 animal, Fido, 2 animal, Rex, 3 animals, then all of a sudden Felix has been destroyed. Now there's only 2 animals. Because in our deconstructor, we print it out, print the name, say they've been destroyed, and decrease the animal counter. Okay? So DEL is how we delete an object, and underscore dunder del dunder is the method that we run whenever we delete something. And we can define that for ourselves if we'd like. And here we did. Okay? Now you'll notice C1 is a cat. Okay? So we came up to cat, and Python said, is there a dunder del dunder here? No, but it said, okay, animal, we inherited. So let's go look down here. Is there a dunder del dunder? Blah, blah, blah. Yes, there was. So it found it, and it used this when it destroyed the object. If it didn't find that, it would have used the superclass one. And that doesn't print anything. That doesn't do anything. It wouldn't have affected our counter. It would have just given the memory space back to the heap, and that would have been it. There'd be no more C1, no more Felix, but you wouldn't have changed your counter. You wouldn't have done anything. It's raw. Okay, you're going to see that in a second. Actually, you're going to see that right now. Okay, because it leads into the third thing we want to look at, and that is this. Think about this. Think about what I'm going to type. Print D1. That's the object holding Fido. What is that going to say? Think about it. When you print an integer, print it out the integer, right? Print it out the number. Print a string, it prints out the string, it prints out the characters, it prints out however you defined it. I said print D1. What's that going to print out? Any ideas? See that bottom line? Main.dog object at blah, 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 blah. What is that? Okay. It's a memory location. A little weird, right? Here's the secret. Integers, floats, strings, they all have classes. Okay? You've learned about classes. You've learned what they're about. All of what we have thought of as primitive types, integers, floats, strings, they all have classes. Okay? And in those classes, there is a method that gets called when we use print on it. Okay? So, when we create our classes, we can what's called override that method. Just like we had speak in cat override the animal method, well, we can take our method for printing and override the main one that we're supposed to use. Now, the method, and I'm going to do it in animal. I'm not going to do it in the small ones. And I'm going to do it right here before our deconstructor. The method is a dunder as well. It's called dunder string dunder, okay? And what happens is this method returns a string. So what we want to do is build a string. And we want that string to say, I'm going to say str colon, and then I'm going to concatenate, and then I'm going to say str, because I want to make sure I return a string plus space plus, and then I'll say str self.wait. And that should be good enough. And then you return it. Don't forget to return it because it expects a string. Okay? So now, ready? Print D1. What is D1? D1 is a variable that holds an object created with dog. I go up to dog. I'm printing it. So because I'm printing it, I'm looking for a method called dunder string dunder. Is it in dog? No. Did I inherit from something? Yes, I inherited from animal. So let's go up to animal. Things are getting long now, right? Do I have a dunder string dunder? Yes, I do. So what am I going to do? I'm going to run it. So a string string self.name. What was it? D1 Fido. So Fido, what's Fido's weight? 35. So I'm going to see str dash self.name Fido plus 35 plus his weight. And then I'm going to return a string. And that's going to get returned to the print function, and that's going to print it out, okay? So instead of this memory location, we have now overridden it, and we're going to create our own little informational string, all right? See if it works. It'd be interesting if it didn't, but it does. So now instead of the memory dump, we now see str Fido 35 because we overrode the default string and told it what to do ourselves. Back in the day when I first became a programmer and I was working with C++, what I would do when I overrode, and it wasn't called string, I forget what it was called, toString or something like, or maybe that's the Java one, but there was a method to overwrite in order to print your objects. And all I did was a data dump. I basically took every single instance variable and I threw it to the screen. I mean, I didn't know what else to do. You could also put together an informative, dump of the different methods that it had, almost like, MAN, a manual thing in Linux or something, where if you printed the object, you got a good description of what it was. You dumped the current state of your instance variables, and then you informed people what different methods could be run on it and stuff like that. There were different ways to do it depending on the context. I mean, sometimes an object, if you print an object, and let's say you're trying to simulate a flower, you just put a picture of a flower up, or a picture of a cue ball, or a picture of something else. It all depends on the context of what you're doing, on what you want when you print something. But in most simple cases, if you're printing an object, usually it's just a data dump of the instance variables and maybe some information about what the methods do. All right. So I digress. So basically what that's about is overriding the default string from the superclass and making sure we have our own in there. Now I did it in animal, but I could have done it in cat and I could have done it in dog. And then I would have the option of saying this is a dog object. Okay, or this is a cat object. I did it here in animal. So it's going to work for either cat or dog because it comes along for the ride when I inherit. All right. All right. Now, one last thing I'm going to do, the very last thing I'm going to do is I am going to show you that I have a whole bunch of code here where I use the classes. Up here I have all my classes. I have animal, which is getting pretty complicated now. Constructor, getters and setters. The speak method does something. I've overwritten my string, so when I print something, it prints out the right thing. I have a deconstructor. I'm keeping a counter to know how many objects I have. I'm inheriting twice, a cat, a dog. I'm overriding the speak method so the proper sound is made when these animals speak. This is starting to turn into a nice, sophisticated little animal library here. And then I take my main thing and I use it all. So, you know, things are pretty good. But I'm a Python programmer, so this annoys me slightly because it's not very compartmentalized. All right? So what I'm going to do is this. Watch this. I'm going to take this right here. I'm going to say control copy, and then I'm going to get rid of it. Oh, boy. That is scary. So I have just my classes now. And what I'm going to do is I'm going to call this my animal library. And I'm going to say file, save as, and I'm going to save it as animallib.py. Okay? Animallib.py. Beautiful. Then, new file. Look at that. I'll call this the main prog. For animals. And I will save it, and I will call it animain. And I will run it. But it's going to blow up right now. All right, watch this. It's going to go, cat not defined. What? Doesn't know what a cat is. Why doesn't it know what a cat is? Because it's all that stuff is over here in the library. So what do I want to do? Don't need this main anymore because everything is main. You know what I'm going to do. From animal library import. And I know what you're saying. You're saying you told us just to use import. You told us not to use from blah, blah, blah. I know. I'm just doing it. So all the code we have downstairs there works. You got no worries. I get it. I get it. Look at that. Import animal, cat, dog. Animal, cat, dog. Only these aren't functions. These are classes. But I can import them just like I can functions and just like I can constant variables. Okay? Classes are just like functions. They're defined. They're sitting off in another file. And I can import them and use them. So that when I call cat here, when I create that object, I've already imported it and it knows. Okay? And when I run this, it's going to have the same behavior as when I ran it the last time there. Please have the same behavior. And it does. See? Only now I've compartmentalized. I have an animal library with my animal, my cat, and my dog. And over here, I have the main program where I'm using it. Okay? So this is where we start to get sophisticated in this animal library. And it doesn't have to be just classes. I could have classes in there. I could have functions in there. I could have a whole bunch of constant variables defined in there. And then what you're going to do is you're going to say, hey, I really like this. I want to give it to my friends and have them use it. And you're going to create what's called an API. You're going to create a list of things to do so other people can use your code and tell them how easy it is to use your code and what to import and what not to import and how to use it and boom, 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 boom. And that's how we get more sophisticated as programmers. And moving forward with data science, that's what we'll do. I mean, I could see in the future you writing code to rip something out of an Excel spreadsheet, manipulate it, and then put it back. Your colleagues are going to be interested in using that. So you would whip up an API and give them the code and give them the way to use it and say, hey, everybody, I wrote a way to manipulate the spreadsheets and do this and do that. And that's what we do in programming. People will ask for things, and that's how we provide them the answers. We write code for them, and then we tell them how to use it, and we send it back. So that's how we compartmentalize this. We take our classes just like we used to do with our function, and we put them out into a library, and then we just use them here. So I'm calling cat, I'm calling dog twice, I'm doing all the other things we did. And when you run that, yeah, you get the same functionality as you did when you ran things before. All right? You have no worries, because I'm going to take Animane, Animal Library, and I think the original Animal is already up there. But if it's not, I'll put it up there. And you'll have all of these things in your resource file for you to use. Okay? Then that's it. That is your whirlwind tour of object-oriented programming with Python. You're going to get a lot of object-oriented stuff with Python from different books and different online resources. And just keep in mind the big picture stuff, classes, how we use them to create objects, how we use objects to work in our programs. These objects have instance variables, and then we have methods that are associated with these objects that we can run that manipulate that data. You have inheritance, code reuse, being able to, have a base class and just base most of your stuff off of it and add new functionality. Polymorphism, depending on the context, two things with the same name can do different things. Now you've added some more tools to your toolbox today. You have class variables so that different objects can talk to each other and share a variable. You have deconstructors, what to do when objects get destroyed. You know about overriding functions in this hierarchical fashion when you're dealing with object orientation in classes in Python. You can override that string method, so when you print your object, you can print whatever you want now. And you have the understanding that you can still keep things modular because you can save your classes in a library as well as your functions and as well as your constant variables. You're going to learn going forward when you look at code and you look at third-party libraries, it's all classes now. All you're going to see is classes. You're going to get an object of that class, and then you're going to be able to run all the methods. You're not going to have functions. You're going to have methods in classes when you get objects. You'll see. And that's it. It's not that hard. Mr. Med is pleased with your progress. All right. That's it. That's the final video for Unit 5. Now, you have all your Unit 5 resources. You have your slides. You have your Zell readings. You have 3, count them 3, review videos. You have your assignment, where you have to create a class that mimics a deck of cards, which is very interesting in a couple of different ways. When you see the way I did it, you're going to be mad. I think this class is going to finish nicely because we have one more in-person meeting. And in that last in-person meeting, it will be after Unit 5 ends. So I will be able to show you how I did my deck of cards. So that's always a fun class. Sometimes the last class happens and Unit 5 isn't over yet, so I don't get a chance to talk about the deck of cards assignment. But we're going to be able to go over a whole bunch of stuff in our last class. So that's going to be cool. Actually, our last class will be when? Tuesday the 25th. So that's actually coming up. A couple of weeks. So make sure that's on your schedule. Right now, you need to know 2 things. 1, Unit 5 is going to end on Thursday the 21st. I'm looking over at my calendar on my wall. Thursday, 21st is a Friday, so I believe it's that Friday, the 21st, that Unit 5 is going to end. So be ready. Make sure your posts get in, 4 days beforehand, around the 17th or the 18th. Make sure your posts get in so people can read them and people can respond. I always like the Rosling video. I think it's a good one. Remember that your proposals are due in 5 days. So get your group together. Think about something. Get things going. Okay, I'm going to read your proposals and then I'm going to approve them. So don't hand in your proposal and then all of a sudden get going on your design doc, because sometimes I make changes. And sometimes I ask for additions. And sometimes I say, this doesn't really work. Think of something else. So, be ready for that in case it happens. Proposals are due on the 16th, so make sure I get those proposals. Usually, when you submit them, I do my level best to get right to them, read them quickly, and tell you whether you get a thumbs up or make some changes or do something. Because I know you're a little pressed for time. This class is going to be over first week in some couple of days in May. So we'll get that done. But right now you're in good shape. Worry about Unit 5. Worry about object orientation. Worry about your slides. Worry about the videos. And then think out of the box and then craft something that you think will work for the deck of cards. And then use it to play the game. Use it to play AC-Doocy. A lot of people have come to me over the past couple of years I've been teaching this class, and they go, I don't know what AC-Doocy is. It's not hard. Throw down a card. Throw down a second card. Then you wager on whether the third card will be in the middle of those two. All right? I consider a tie a loss. I don't play around with ties. Some people push for ties and do some other things. And then if you win the money, you take money out of the pot and you put it in your pile. If you lose, then you take money out of your pile and put it in the pot. And that's it. And then you go again. All right? Because I want you to do a class for a deck of cards, but then I want you to instantiate it and get an actual deck that you can use in a program. And then, get cards from and do what you would do in a regular card game. Okay? All right. I think you're going to be okay. All right. So you keep chugging along. I will be in touch every 2 or 3 days to keep you going along, to give you updates, to make sure you know about deadlines, to make sure you're happy. Any questions, please put them in the forums. If there's something that you think all your classmates can benefit from, please put them in the forums. And we can take care of it that way. But, of course, you can always email me. All right? I sent out Unit 4 grades. You should all have gotten them. You're all doing very well. Just please keep doing what you're doing because this is a very, very good class. All right? All right. Then you be good and you get out of here. And I will be in touch via Sakai announcements. And we will see each other in a couple of weeks. And you're fine. You got a lot of time to play around with your Unit 5 stuff. All right? All right, good. Then I'll see you soon. Bye.